Hello class, welcome to this video on 6.2 on AP Stats, transforming and combining random variables. So we want to describe the effect of basic transformations on random variables, and we want to find mean, standard deviation, and probabilities for the sum or difference of random variables. So the first learning target is talking about the effects of adding or subtracting a constant or multiplication and division on the probability distribution. So there's only 3 learning targets in this lesson, but this lesson is pretty involved, especially when you get to learning target 2 and on. First learning target is not so bad because we've seen this stuff before in a previous chapter. So it says here a review question: an American roulette wheel has 38 slots numbered 1 through 36. Plus 0 and double 0. Half of the slots from 1 to 36 are red, the other half are black. Both the O and the OO slots are green. Suppose that a player places a $1 bet on red. If the ball lands on a red slot, the player gets the original dollar back, plus an extra dollar for winning the bet. If the ball lands in a different colored slot, the player loses the $1 bet. And so it says let X equals the net gain on a single $1 bet on red. Fill in the probability distribution below. So then what are our possibilities here, right? So there's two potential possibilities. You get the dollar back plus an extra here. And then if it doesn't, then the player loses, right? So the values here are whether they win or lose, whatever, what's the value that they win or lose. So let's talk about if they lose $1. So here we have they lose $1, and here they have they gain $1, right? Okay, so X is the net gain. So either they net loss or a net gain of $1. Okay, so then the probability. What's the probability of a net loss? Well, as it mentioned here, it says half of the slots from 1 to 36 are red, right? So that means there's 18 red, there's 18 black, and then there's 2 green, right? The 2 green are the 0 and then 0 slots. So if you place a $1 bet on red, right, there are 18 red, then there's an 18 out of 38 probability that you would win if it, went on red. And then there's a 20 out of 38 probability that it's not on red, 18 black and 2 green. So if it's on neither of the red slots, well, then you lose $1. So what's the expected loss here? How much on average will we expect to lose or win? We know that there's a greater chance of losing, so we know that overall it's going to be a loss. So what's the expected value or the average? Okay, so we talked about this in the previous lesson. To calculate the expected value or the mean, you multiply the x times probabilities and you add them together. All right, so we got -1 times 20 out of 38, the x value times the probability, plus the x value of 1 times the probability of 18 out of 38. And you add them together, so you get a net loss of a loss of 5 cents. So what we can interpret from this is that if we play many games, we would expect to lose on average 5 cents for every $1 bet we put in. All right, so we would lose 5 cents. Hence, that's why it's a negative, over many games. Remember, it's a probability, so you want to introduce the idea of many, right? Law of large numbers. Now, find the standard deviation. So this is a formula that we talked about in the previous lesson. So we can basically subtract the x value from the mean from the x value, square it, multiply by the probability, and then you add the results together with the square root. Okay, so we get the square root. The x value was -1 minus the mean value that we just found was -0.05, right? So we're going to subtract that, so minus 0.05 here. Okay, should be an extra negative here. Minus -0.05 squared. There's a double negative there, which turns into a positive, times the probability of 20 out of 38, plus, now we got the next x value was 1, we gain $1, minus the -0.05 squared, times the probability of 18 out of 38. And of course, you can turn this into a positive. And you'll get approximately $1. You get 0.998 or something like that, 0.999, which is about $1. All right. So in that case, to interpret this, this is the variability. This is how much we would see the spread. Okay, so we would lose an average of 5 cents, right, over many games, but the spread of that is going to be $1, right? So it's going to vary about that by that much. Okay, so if many games were played, the amount of money a player collects will typically vary. So on average, they'll typically vary by about $1 from the mean expected value of 5 cents, of -0.05. All right, so now note, this means that if you play only a few games, then your actual net gain could be much greater or much lower than the expected value, because the variability is pretty high. So yes, on average you would expect to lose, but the variability is high. And so you could make money if you add plus $1 to this, well, then that's 95 cents, right? Because the variability is different. But you can also go on the lower end and subtract $1 from this on average, and it would be -$1.05. So you get that variability. Okay, so it could be much greater or much lower than the expected value. All right. Okay, so let's look at our first example here. These examples are going to be, in this lesson, are going to be fairly involved. But recall the example from 6.1 about Jeep tours, Pete's Jeep Tours. They offer a popular day trip in a tourist area. There must be at least 2 passengers for the trip to run, and the vehicle will hold up to 6 passengers. Pete charges $150 per passenger. Let C equals the total amount of money he collects on a randomly selected trip. The probability distribution of C is shown on the table. Okay, so we got the probability distribution, the same one from that lesson. And we have the histogram that we created on that day, on that lesson. So if you look at the shape appears to be roughly symmetric, right? Roughly symmetric, with a single peak at 600. Okay, so that's what we were saying. We got our center and our variability. It costs Pete $100 to buy permits, gas, and a ferry pass for each day trip. The amount of profit V that he makes on a randomly selected trip is the amount of money he collects minus $100. Okay, so we want to define a random variable called the profit. Okay, so if he spends $100, then that means whatever he makes minus $100 is his profit, right? So we're going to define the random variable V as being C minus the $100, okay? All right, so now we're looking at a new random variable, V. Okay, So now what we're going to do is we're just going to adjust this. So if this is going to be, remember that here he made $300, so it's 300 minus 100 is going to be the profit V, right? Okay, here was 450 minus 100, so on and so forth, but I'm not going to show all of these. Okay, the next one was 600 minus 100, which is 500. Yeah, 650, and we got 800. Okay. So then there's our probability straight from the table here. All right, so that's our new probability distribution for the random variable V. So now what we're going to do is we're going to see how that affects the shape of the distribution, the mean, and the standard deviation. That's our goal. So draw a histogram. So, all right, so let's go ahead and draw a histogram, and then we'll calculate the mean V. All right, so we got, we're going to scale this. We have 200, 350. We're not going to put 0 there. So we can cross that out. You got 500, 650, and 800. Okay, so it's 0.15. We got 0.25. 0.35, 0.20, and 0.05 for the probabilities. Okay, there's a histogram. Notice that the histogram, the shape didn't change. Still the same shape here. See that? Still symmetric. Still, but now it still has a single peak. However, the single peak is different because it's 500 instead of 600. All right, so let's do the mean. So the mean, we're going to do the x value times the probability, right? So the x value, which is 200, times the probability, which is 0.15, plus the next x value times the probability, plus dot, dot, dot. And if we do that, we get $462.50. We'll show you how to do this on the graphing calculator in just a second. We'll remind you how to do that. All right, and then we'll show you how to do standard deviation as well where we're at it. But you get this, so let's just practice the standard deviation. So we have to do the x value minus the mean. The mean we just calculated was 462.50. Okay, squared times the probability, which is 0.15. And you just repeat that, dot, dot, dot. Do that for 350 minus 462.50 times 0.25, and so on and so forth. All right, and we get $163.46. All right, I'm going to show you how to do this on the calculator because throughout the lesson we're going to be calculating these and we're going to need to do them quick, okay? All right, so we're going to show you this on the graphing calculator. So again, you're going to go to Stat, and then you're going to go Edit, and here we go. So we got this here. So we're putting in the x values, then the probabilities here. All right, and so then we're going to, after we plug in the x values and the probability values, we're going to go back to Stat, Calculate, and then one variable Stats. Make sure list 1 is selected for that, and then for frequency list here, we're going to select list 2. So we're going to hit second stat to access the list, and that would be list 2. And then go down to calculate. We got our thing here. So here we got our mu, which is 462.5. That's what we had earlier, and our standard deviation was 163.46. So that's what we got earlier. Okay. All right, so now that I showed you how to do that, let's go ahead and continue. So we have our mean and our standard deviation. So notice what happened. The mean was 562, and now it is 462. So the mean decreased by 100, right? And the standard deviation, 163.46, did not change, okay? So the variability does not change when I add or subtract a value, okay? This works for addition as well. The mean does change by how much I added or subtracted. Okay, so that is the key, but the shape does not change. Okay, so does addition, subtraction by number change the mean? Yes, it does. And in this case, the transformation is reflected by the exact amount that you added or subtracted it, right? Okay, so in this case, the effect is, so we're gonna, let me just change this to mu x like that, prime, because I didn't put it as a subscript there, so I got to change that. Okay, so mu x prime, prime indicates a transformation, okay? So it got transformed. This is equal to the original mu x plus or minus whatever effect you had, okay? So whatever you added or subtracted. Okay, so in this example, it was mu x prime equals mu x plus 100 or minus 100 in this example, right? Now, did it have an effect on the standard deviation? No. So the effect was that it did not change. Sigma x prime is equal to sigma x, okay? All right, did it affect the shape? No, right? The shape remained the same, so same shape. Okay, so addition or subtraction does not affect the transformation. Go ahead and pause the video and see if you can try the following problem here. All right, hopefully you paused the video and tried it before seeing the solution. So in the large introductory class, the score of a randomly selected student on a test worth 50 points can be modeled by a normal distribution with a mean of 35 and a standard deviation of 5. Due to a difficult question on the test, the professor decided to add 5 points to each student's score. So we have the score X, and then we have 5 points. Let Y be the scaled test score. Oh, okay, so Y is the scaled test score. So describe the shape, center, and variability. Okay, so the random variable Y is equal to the random variable X plus 5 points, right? So the shape, if I transform it, is still going to stay the same, right? It was a normal distribution, so it's going to stay a normal distribution. So shape does not change. The shape is normal distribution. Okay, so the same. The center here is, well, the center is going to, we know that it says the score X of a randomly selected student on a test worth 5 points can be modeled with a mean of 35. So we know that mu X is 35, right? Mu X is equal to 35 at a standard deviation of 5. And we know that sigma X is equal to 5, according to that. So if we add 5 to the test score, is that gonna affect the mean? Yes, it's gonna affect the mean. So in other words, mu of Y is equal to mu of X plus 5, which is equal to mu X plus 5. Okay, so notice how I put that. I substituted Y for X plus 5 so that you can see that, okay, this is going to change by doing mu of X plus that 5, okay? And when we do that, we get mu of X is 35. 35 plus 5 is equal to 40. All right, I want you to get used to this idea of doing this substitution here and then figuring out how it transforms. Get used to that idea because you're going to need that skill in this lesson later on. All right, now the variability sigma Y is sigma X plus 5. However, does that affect the standard deviation? No. The 5 doesn't do anything. It remains sigma X, which is equal to sigma X is 5. Okay? All right, so that's it. All right, so example 1.2. Suppose professor in the previous problem decides to convert the test scores to percentages by multiplying by 2. So we're multiplying the previous score by 2. The previous score was Y, the test scores, okay? So the previous test scores was the Y. Let's calculate the center and variability of the resulting distribution, and we'll call it random variable W. All right, so you have the graphs here. We'll get to that in a second, but let's define the random variable. The random variable is 2 times Y. right? W is equal to 2 times the test score from the previous problem. Now look at the shape. This is the original, this is W is the transformed, right? Notice that the transform is still normal distribution. So still the same shape, right? The shape has not changed. Still normal distribution. So it appears that multiplication does not affect the shape. So multiplication or division do not change the shape. Still remains a normal distribution. Now the center, and there's and I'll clarify, there's a caveat to that, but in general, it doesn't change the shape. Now, if you put a negative, then of course that could change the shape. But if we're just talking about strictly positive numbers, you don't change the shape. Okay. Now, the center here for sigma y was 40. The center here for sigma w is 80, which is 2 times 40. So it appears that the center gets affected as well by whatever operation we did. So sigma w is equal to sigma 2y, which is equal to 2 mu y, which is 2 times 40, or 80. Okay. Now the variability, did the spread change at all? Okay, well, let's look at it. The spread did change. So if you look at it, the sigma here, the sigma y, they said was, we calculated sigma y to be 5, right? In the previous problem, right here. Sigma y is 5. So that's the spread. However, look how much the spread is here. The spread here, that same sigma y, if I go to this point, the same identical point on here, right? Look how much it's changed. It's changed by about 10. You see that? Sigma w is about 10 here. So it looks like the spread doubled. So it looks like it did the identical thing to the spread, where you double it because you double the variable. Okay, so sigma w equals sigma 2y, which is equal to 2 sigma y, or 2 times 5, or 10. Okay? All right, so now you got sort of the rule here. All right, and we'll summarize this. We should be able to summarize this in a sec. Does multiplication and division by a number b change the mean? Yes. Does it change the standard deviation? Yes. Does it change the shape? No. Okay. And we're going to write the general rule here. Okay. So what happens if we multiply by a negative number or divide by a negative number? Would the transformation change the mean? Yes, of course. So we're gonna say a negative number, but it could be a positive or negative, whatever, right? We know that, again, change this to the mu x on the bottom. So the mu prime x is equal to mu prime bx, right? Where we multiply by b. It's going to be b mu prime x, okay? So whatever b is, it's going to make it multiply by b. So if b is negative, you're going to have a negative number, okay? Now, if you do it for the standard deviation, though, look at this. Mu prime x with a b. If we multiply by b, let me just put a b here, then it's not going to make the spread negative. You're going to do the absolute value of b. Okay? So if b is negative 5, then you're going to do the absolute value. It's going to be 5. All right? The spread can never be negative. The mean can be negative, but the spread cannot be negative. Okay? We're talking about the standard deviation. All right, so now what effect does it have on so it does change the standard deviation, and it actually does change the shape. It flips the shape. Okay, so it has an effect of flipping the shape. So I'm going to put a caveat here. I'm going to say most of the time. For most shapes, it will change it because it flips it. Now, some shapes are symmetric, so when you even if you flip it, it's not gonna, it doesn't look like it changed it, right? But technically speaking, it does flip it, and so you have to keep that in mind. All right, so note, how does multiplication by number b affect the variance? So we talked about how it affects the standard deviation, right? We said that it would be absolute value of b times the sigma of x. So now that we know what that transformation does, okay? And of course, this is for multiplication, right? So obviously do the same thing for division, okay? So I said multiply or divide by a number b. So let's just put an example here. So let's say I had the variable was, I don't know, let's say I did x divided by 2, right? Something like that. And let's make it a negative 2. So let's say negative, or x divided by negative 2, right? Let's do that. Well, okay, well that's division, but you can also express that as multiplication. So you can express it as negative 1/2 times x, right? So you can always express division as multiplication. And therein lies therein lies what we need to do. So now if I wanted to do sigma x prime, which is, sigma x prime, or not sigma x prime, sigma prime x, sorry, which is the sigma prime negative 1/2 x. So now I got to do absolute value negative 1/2 times sigma x. And the absolute value of negative 1/2 is just 1/2, right? So I'm basically just taking the sigma x and then dividing it by 2, right? Again, the same idea. So this is just an aside example, just so you can see how it works, okay? Multiplication division it has the same effect on the standard deviation. Okay, so all right, so how does multiplication affect it? So now how does it affect the variance? Now the variance is squared, right? So it's just going to be b squared, right? Absolute value b squared, sigma squared. So however, it doesn't matter that you have the absolute value because any number squared is always positive, and so you could just drop the absolute value, okay? You don't need the absolute value anymore. All right, so there's the rule for the variance, okay? I'm just gonna underline those. All right, so go ahead and pause the video and see if you can try the check for the transformation. All right, so let's look at the following question. It says, El Dorado Community College considers a student to be full-time if he or she is taking between 12 and 18 units. The number of units that a randomly selected El Dorado Community College full-time student is taking in fall semester has the following distribution, along with the histogram shown. All right, so this is the probability distribution for x equals the number of units. Okay, so this is x equals the number of units. So this is x here. So this is going to be xi. All right, so we need to find the mean, right? So the mean of this distribution currently, again, we would just remember to find the mean. You take the x value times the probability, right? X value times probability, dot, 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 and we would get the mean. Now, we could do this on the calculator. I've already shown you how to do that, and so I'm not going to do that here, okay? So you get equal to 14.65. All right, now the standard deviation is square root. Now you take the x value minus the mean that we just got, squared, multiplied by the probability, and you repeat that, dot, dot, dot. And then again, I've showed you how to do this on the calculator, so I won't show you here. Yeah, 2.056. Okay, so that's the original distribution. Now, let's do the transformed. At El Dorado Community College, the tuition for full-time students is $50 per unit. That is, if T is equal to the tuition charge for a randomly selected full-time student, then T is equal to 50x. Okay, so $50 per unit, so 50 times x. Now find the shape, mean, and standard deviation. Okay, so we have our new random variable. It is multiplication. Does multiplication affect the shape? No, right? Neither addition, subtraction, multiplication, division, neither of those affect the shape. Okay, so the shape is going to be, well, what's the shape of this? Let's write it out. The shape of this is roughly symmetric. It appears to be roughly symmetric, so it has that shape kind of like that, but it appears roughly symmetric. Roughly symmetric. And it has 3 peaks though, right? We have the 3 peaks there with 3 peaks at 12, 15, and 18. And so that's going to be the same shape here, okay? So this is going to be a repeat of that, okay? So roughly symmetric. Three peaks at, what were the peaks? They were 3, 12, 15, and 18. So the shape is not going to change. Well, I'm going to say at 3 with 3 peaks here, but the peaks are not going to be at 12. I just thought of it. So the peaks are not going to be at 12, 15, 18, right? These are going to be multiplied by 50, right? So we should really clarify that. So peaks at 12 technically is 12 times 50, right? 15 times 50, and then 18 times 50. So the peaks are going to be technically at those values because we're multiplying by 50. Although the shape doesn't change, the locations of the peaks are different numbers. Okay, so the mu t. So remember that t is 50x. So it's mu 50x, right? And that, remember what that does, it multiplies the mean by 50, right? So it's 50 times and then 14.65, which is $732.50. All right. And then sigma t is equal to sigma 50x, and then that's going to multiply the result by 50. And you would do absolute value, but it doesn't really matter because it's positive, right? And then the standard deviation was 2.056, as we calculated earlier, which is $102.80. Now, if you did this and you got a similar value, it just depends how you rounded this, right? So that means you're on the right track. You can see if you're on the right track if you got similar values here and here. All right. So now let's look at example 1.3. So this is still part of the same learning target, okay? Learning target 1, because now we're looking at combining the operations, a multiplication and addition, whatever. El Dorado Community College charges each student a $100 fee per semester in addition to tuition charges. So you get a $100 fee in addition. Okay, so this is the variable. All right, so let's calculate how that would affect the standard deviation. Well, so this is going to be mu 50x plus 100 on the bottom. And remember that multiplication affects the mean, so it's going to become mu 50x plus, and addition affects the mean, 100. So the 100 is going to add to the mean to be 100, and then we're going to break this apart now. The 50 multiplies by the mean, like that. So I want you to practice manipulating that mathematical piece. So notice how I broke it apart. Mu 50x plus the 100, and then the 50x becomes 50 mu x, right? Simple, but you want to make sure you understand how to do that. And then 50 times the mean was, it was 14.65. originally, and then plus 100. So it's going to be $832.50. Okay, now here is sigma 50x plus 100. Now addition does not affect the standard deviation, so this becomes the same thing as sigma 50x, okay? Addition doesn't affect the standard deviation, the spread. And then this becomes 50 sigma x. So we get 50 times 2.056. So again, it's the same result that we had in the other problem. Okay. So the standard deviation doesn't change from this, but it did change from what it originally was, of course. Okay. All right, guys. So those are the different operations. So now in general, we have here a linear transformation. Okay. So this transformation right here, the 50x plus 100, that's a linear transformation. Okay. The linear transformation is of the form y equals a plus bx. In this case, the probability distribution, notice it has the same shape as the original distribution, as long as the b is greater than 0, meaning the b is positive, okay? B is positive. If b is negative, of course, it's going to flip the shape. And so we see here, let's just call this mu with the y, the little y, sigma, or a sigma with the y on the bottom. So we get mu a plus bx, which is equal to a plus b mu x, okay? So this is like the general sort of rule that we have, okay? So we get that the mu of that transformation becomes that. The mu of this linear transformation, remember, showing our work, a plus bx, the plus a doesn't do anything, addition doesn't do anything to the standard deviation, but the multiplication does. And so we get b, absolute value b, sigma x. Okay, so these are your sort of rules for linear transformations. Okay, go ahead and pause the video and see if you can try this problem based on what we just had done. You could do A, B, and C, and you may not need to do D, but just practice at least the mean, standard deviation, and then at least that part. All right, so hopefully you practice at least A and B because that's what we had done, those transformations. So let's look at this one here. And then C and D are extra parts that we need to complete the question, but we want to at least have you do A and B. One brand of baby bathtub comes with a dial to set the water temperature. When the baby safe setting is selected and the tub is filled, the temperature X of the water in a randomly selected bath follows a normal distribution with a mean of 34 Celsius and a standard deviation of 2 Celsius. Let Y be the water temperature in degrees Fahrenheit for the randomly selected bath. Recall that, so here we want to convert from, Celsius to Fahrenheit, and so we got our transformation there. Okay, so because we want to be able to convert the temperature, F is equal to 32 plus 9/5 C, because it's in the water temperatures in degrees Fahrenheit here, okay? And for the Y, we want to find the mean of Y. Okay, so the mean of Y is equal to the mean of that linear transformation. But the 32, what that 32 does is just adds, right? According to what I talked about. Plus, and in the 9/5, it's just going to multiply the mean by 9/5, the mean of C. Okay, there you go. Now the mean of it says that the mean is 34 degrees Celsius. That's the mean C. So we're going to multiply by that to get our result. Okay, so then that becomes 93.2 degrees Fahrenheit. Okay, so that's the mean of y. Now calculate and interpret the standard deviation. We're not going to interpret here. I'm going to explain the interpretation, but I'm not going to write it. I just wanted you to calculate it. I put interpret there, but I didn't give you enough room to do that. So it's just going to be a calculation. But we'll talk about the interpretation. All right, so the sigma y equals sigma 32 plus 9/5, right? But remember, the addition doesn't affect the standard deviation, so we're going to ignore it. And it's just going to be 9/5 times the standard deviation of C. Okay? So it's 9/5 times the standard deviation they told us was 2 degrees Celsius here. So we'll multiply that, and we get 3.6 degrees Fahrenheit. All right, and then the interpretation of that is, so in this case, over many samples, or over many, in this case, it says here, temperature of the water, okay. Yeah, so over many randomly selected baths, right? Over many randomly selected baths, the temperature typically varies from the mean of 93.2 by 3.6 degrees Fahrenheit. So that's the general interpretation, okay? So over many randomly selected baths, the temperature will typically vary by 3.6 degrees Fahrenheit from the mean of 93.2 degrees Fahrenheit, okay? All right, so now we know it says that it's normally distributed, and so we know that it says we want the normal distribution for the random variable y. Okay, so this is for the random variable y, which is, which we know what that is. I'm just going to put y there. All right, so the middle is going to be the 93.2 because that's what we just calculated, right? So we got 93.2, and I'm just going to put this as in degrees Fahrenheit. Okay, and now we're going to add 3.6 to the right and to the left, okay? This is a review of chapter 2. Okay, so remember from chapter 2, we start with the median or the mean in the center, and then we add and subtract the standard deviation to get each of the values here, okay? So we're going to add another 3.6 to 93.2. We get 96, oops, sorry about that. Get 96.8 here. Yeah, 90. All right, and then continue doing that. So we get 100.4, and then 104. And then subtract 3.6 to get 89.6, 86, and 82.4. Okay. All right, so now we labeled it. So now part D is find the probability that the temperature of a baby's bath water is between 90 degrees and 100 degrees Fahrenheit. Okay, so again, we've done this in chapter 2, but just as a review, we take the value minus the mean divided by the standard deviation. So in this case, we get the variable is y, so y minus mu y divided by sigma y. Okay, so here we got, so the y value is, in this case, 100 degrees Fahrenheit, right? So we get 100 minus mu y is 93.2 divided by the standard deviation is 3.6. We get to see the, so that's, oh, it says between 90 and 100. Okay, so sorry about that. So let's take this, and I'm going to move it over here. Sorry about that. So that's going to be our, hold on a second. I don't want to move there. I'm going to move it here. Sorry about that. Okay, so that's going to be Z2 because we got 100 is going to be my second y value. I'm just going to call it y2. And then it says between 90 and 100, so then that's going to, 90 is going to be y1. Okay. All right, so we got 100 here minus that, and then we got 90 in blue minus 93.2 over 3.6. That's what we got. So for the z-scores, we get 1.89 and negative 0.89. And so then we want the probability that's between 90 and y, which we already calculated those z-scores, is negative 0.89 and 1.89. And so if you want to calculate this, you need to look both values up on the z-table and then subtract them, okay? So we're going to look up the value for 1.89. We're going to look up the value for the smaller one, negative 0.89, and then we're going to subtract those two values together. Okay, so let's look up those values, 1.89 and negative 0.89. Okay, so we're going to look up 1.89. So 1.8 right there, 9, 1.89, okay, and then we're going to trace that down. So we got 1.89, so 9706, okay, so that's that one. The next one is negative 0.89, so we go to the negative part of the chart, negative 0.89. I don't have the negative part for that. Hold on a second. Oh, there's some other values. Hold on, let me get the other table. Hold on, it might be over here. There it is. Okay. So negative 0.89, negative 8, okay, and then 9. So that's going to be 0.1867. Okay. So you look both those values up, subtract them, and get your answer, get your result. All right, so here we go. Let's go ahead and do that. So we get 0.9706 minus 0.1867. We get 0.7839. All right, so now we're going to show you this with technology. Most of the time this is what you would use, but they do give you the table on the AP exam. So we're going to show you how to do this on with technology real quick. Just make sure you get it. All right, so there's a couple ways to do it, with standardizing and without standardizing. Okay, without standardizing, we'll do that first. Without standardizing means you're not going to be doing the z-scores. You're just going to plug in exactly what you have. So here you're doing between 90 and 100, right? So let me shade. I forgot to shade this, by the way. So let me do that here. So it's between 90 and 100. So the upper value is 100, the lower value is 900, right? So that's what we're going to be doing. So the lower value is 100, the upper value is the lower value is 90, the upper value is 100. The mean was 93.2. And the standard deviation was 3.6. And so if we do this on the calculator, you get 0.7835. And we'll show you this on the calculator in a second. Now with standardizing, that's with Z, okay? So you're going to be using the Z-scores. So in this case, the lower value was negative 0.89. That was the first Z-score that we got. Remember Z1? The upper one was 1.89. That's the z-score for Z2. That's what we got earlier. The mean is 0 for the standard normal distribution. The mean is always 0, okay? And then the standard deviation is 1 for the standard normal distribution. Okay, in that case, you would get 0.7839. Okay, so again, when you go to your table, see if I can find the table here. The mean for this standard normal distribution is zeros, and then it goes by ones. Okay, so the standard deviation is 1, but the mean is 0. Okay, that's the review. All right, so I'll show you how to do this on the calculator. All right, so let me show you this real quick. Again, this is gonna make the video take longer, but just to review, because we had done this in chapter 2. So we want to go to vars, or so second vars, and then go to normal CDF, and then we got our lower and upper. I'm just going to show you one of them. I'm not going to show you both of them. Let's do the without standardizing, or yeah, without. So without standardizing, you get 90, 100, and then the mean is 93.2, and standard deviation is 3.6. And you paste that, enter, 0.7835. That's what I was telling you earlier. All right, so either way, you get about 78% probability. So when we set it on baby safe mode, there's a 78% probability that the water temperature meets the recommendation for a randomly selected bath. All right, that's going to be it for learning target 1. All right, so now we're going to learn target 2, calculate the mean and standard deviation of the sum or difference of random variables. All right, so let's return to the Pete's Jeeps tours, right? That example there. It says, let's consider a different random variable x equals the number of passengers on a randomly selected trip. Here is its probability distribution. Okay, so let's calculate the mu x. Remember, to calculate the mu x, you do multiply the x by the probability, and add them. Okay, so 2 times 0.15 plus 3 times 0.25 ... Okay, and we get $3.75, or 3. I'm sorry, they're talking about the number of passengers, not money. Is 3.75 passengers. Okay, not dollars. Okay, and then the standard deviation, again, you do the standard deviation, you can calculate it. We do the square root, we do the x value minus the mean that we just found, times the probability, repeat that, and you get 1.0897. Okay, so there's your 1.0. Let's round that. Yeah, so we'll just leave it like that. Okay, so now Pete's sister, Erin, runs Jeep tours in another part of the country on the same days as Pete in her slightly smaller vehicle, under the name Erin's Adventures. So now her passengers are going to be called Y, okay, the number of passengers. Again, let's do the same thing, 2 times 0.3 and so on and so forth, okay? And we get $3 or 3.10 passengers, sorry. And then again, similarly, we're going to do the standard deviation. We get 0.943. I would highly suggest writing it out, but since I've already shown you how to do it in the first part, I won't do it here. Okay? Okay, so again, we do this on the calculator to get the solution. We don't have to necessarily do all these calculations, all right? Because I've shown you how to do that on the calculator. All right, so now what we're looking at is part A. What is the distribution of x plus y? So if we combine Pete's and Erin's businesses, how many passengers will they have on average? Okay, on a randomly selected day. Okay, so that's what we're doing. We're combining the results here, x plus y. Okay, so that's what we want to figure out. How does that affect the result? Okay, so we're going to need to construct the probability x plus y. Okay, and we're going to call it the variable s. Okay, for sum. So let's go ahead and do that. So first off, to get a sum of 4, we would have to do 2 plus 2, right? Because if you look at the distributions for them, you can only get a sum of 4 by doing 2 plus 2 according to these two tables, right? So let me go ahead and do that. Hold on a second here. Okay, so we're gonna combine these. Okay, so to get a sum of 4, I can do 2 plus 2, right? Now, how would I get a sum of 5? I could do 2 plus 3. Or I could do 3 plus 2. So I could do 2 plus 3, or I could do 3 for Pete plus 2 for Erin. So there's 2 ways to do 5. What if I want a sum of 6? If I want a sum of 6, there's 3 ways to do that. 2 plus 4. I could do 3 plus 3, and then I could do the 4 plus 2. Okay, so you got to consider that there's multiple ways to get a sum. Okay, all right, so that's what we're going to do here, right? So there's 2 plus 2. We can do here 2 plus 3, and then 3 plus 2. All right, so on and so forth. Okay, so let's calculate the probability of getting a sum of 4, 5, and then 6. All right, we're going to try to do that. All right, to get the probability for any value of s, x and y must be independent from each other. So Pete's business and Aaron's business have to be independent from each other. So that's what we're assuming from the get-go, which makes sense to assume that. This means knowing the value of one variable does not or doesn't change the probability distribution of the other variable. All right, so to get s equals 4, we said that we would have to have 2 plus 2, right? X equals 2, y equals 2. So probability of x equals 2, probability of y equals 2. Now we have to do and, okay? So x equals 2 and y equals 2. Remember that when you have and probabilities, you multiply them, okay? That was the general multiplication rule. You multiply the probabilities for and, okay? All right, so the probability of 2 for Pete, and again, I wish I had this on the same page, but I unfortunately I do not. Here, if you go back, you get x equals 2. So you get 0.15 times 0.3. Those are the two probabilities. So we can multiply those two probabilities, okay? All right, so we get 0.15 times what was the other value? It was 0.3, yeah. And you multiply them, you get 0.045. So this becomes 0.045, okay? Again, I'm doing this exercise so you understand how we come up with these probabilities, okay? All right, so that's how we get that. So now to get s equals 5, we said there are two ways, 2 plus 3 and 3 plus 2, okay? So x equals 2, y equals 3, or x equals 3, y equals 2. There's two ways. So we're going to have to combine the two ways with addition, okay? But to get each individual way, we have to do multiplication. Okay, so x equals 2, y equals 3 means we multiply those. So you go back to the table for Pete, x equals 2 was probability of 0.15. For Aaron, y equals 3, the probability was 0.4. Okay, I'm not going to go back to the table, just go back to it yourself and find it. So 0.06. All right, so x equals 3 and y equals 2. For Pete, x equals 3. The probability for Pete's table was 0.25. The probability for Aaron for 2 was 0.3. And you get 0.075 when you do that. Now we're going to combine these two results. So we get 0.06 and 0.075. Combine them, or right, adding, and you get 0.135. Okay. Now to get s equals 6, there are three ways, right? You can have Pete's x equals 2 or Aaron's x equals 4. You can have Pete's x equals 3, Aaron's y equals 3. Or you can have Pete's x equals 4, Aaron's y equals 2. All right, so we got 2, 4, 3, 3, 4, 2. All right, so three ways. So 2 and 4. So that means Pete's x equals 2. The probability for x equals 2 for Pete was 0.15. For Aaron, the probability, the table for Aaron, 4, was a probability of 0.2. So we multiply those to get 0.03. Is it correct? I got to change that. All right, 0.03. Now this one was 0.25, and then this one was 0.4, and you get 0.1. Now for the Pete's x equals 4, the probability was 0.35, and the Aaron's y equals 2, it was 0.3. And then you multiply those, so you get 105. Sorry. All right, so now we add those together. So we get 0.03 plus 0.01 or 0.1, sorry, plus 0.105. Add those three, we get 0.235. All right, so let's put that over here. So we get 0.135, 0.235. All right, folks, that's how we get these probabilities right here, okay? So that's how we get this probability distribution. So we've done 3 of those numbers. We do not have to do the other numbers because they're already filled out for us, but that's how you would find them, okay? You can do this for all of them, all right? So to get 11, you would have to do, you would have to go here and then say, okay, how do we get 11? Well, 5 plus 6, right? And so we would do 0.05 times 0.1. And we do that, and that's 0.005. So you can get all of these values, okay? So I just want to make sure you know how to do that. Okay, so let's go down here. So now we can calculate the average of the sum. We multiply the sum 4 times the 0.045, 5 times 0.135, 6 times 0.235, so on and so forth. Add them together, okay? Again, I'm going to just show you a couple of those steps, but we'll do it on the calculator. You would be expected to do this on the calculator, right? To know how to do it on the calculator. 0.045 plus ... all the way to the last one, 11 times 0.005. And you get a sum of 6.85 passengers. So remember that Aaron's sum, Aaron's sum we calculated was 3.10. And Pete's sum is 3.75. So if I combine 3.75 plus 3.10, that gives me 6.85. Well, that's what I got here, right? 6.85. So simply, I don't have to do all this math, right? I can just get to the result. But I did this so that you can see, okay, well, yeah, I did get 6.85. So now we can basically do a shortcut and just say, okay, well, the mu s, as in s is on the bottom, is equal to mu of x plus y. And so I could just add those two separately. So mu x plus mu y. And so then we could just add those. So we had, what did I say? It's 3.75 for one of them and 3.10 for the other, right? Was it in that order though? Let's see, 3.75. Yeah, 3.75 and 3.10. So the Aaron's was the smaller amount. Okay. All right. So that's what we have, and then you get 6.85. All right. So now we know a shortcut. Just add the averages for the two separate ones, and you get the result. All right. Now let's look at a standard deviation, though. Okay. So standard deviation, we have this formula. Let's calculate the sigma s for that. This is the variance actually because it's squared. So we're going to just look at the variance for now. So this is the variance with the squared. All right, so we got 4 minus the sum was 4, right, for the first sum. You look at it here, the first value, minus that 6.85 squared times the probability for the 4, which was 0.045, plus ... Just repeat that. No square root because we're dealing with the variance. And then you get the variance is 2.0775. Okay, and we'll do this. We'll do the standard deviation as well while we're here. The standard deviation is the square root of that number. Okay, which is 1.441. Okay, now we got both of them. We got the variance and the standard deviation. But right now we're going to focus on the variance. Okay, here. So I want you to notice a couple of things. Okay, for the variance is actually equal to the sum of the two variances. Okay, I'm going to point this out to you so you can see it. Sigma x which is what we got for Pete, was 1.0897. Now Aaron's sigma x is 0.943. So we're going to be using those two values, all right? So notice that if we do 1.0897 squared and 0.943 squared, we get 1.1875 plus 0.89. Again, just walking you through the math, you get 2.0775. That's exactly what we got, guys, right there. Okay, so the variance is simply the sum of the two individual variances. All right, it's not, notice that it's not, that the standard deviation is not sigma x plus sigma y. Because the standard deviation, if I add those two together, I get 1.0897, I get 0.943. If I add those together, I get 2.0327. Now, is that the same as that? No, right? They're not the same. So the standard deviation is not, you can't just add. So basically, if I do this, that is not the same as sigma x plus sigma y. We can see that. However, if I square it, it is, right? So if I do this, this is equal to sigma squared plus sigma squared y, okay? That is true, but the non-squared version, I can't just add them. All right, so that's important to understand. It's really important to understand. Okay, so in that case, in other words, the variance of the two independent random variables is simply the sum of their variances. To find the standard deviation, you had to take the square root of the variance. Okay? All right, so to find the standard deviation, we know that sigma squared s, which is sigma squared x plus y, we know that that's equal to sigma squared x plus sigma squared y. So if I take the square root of that, that gives me the standard deviation. So the square root of sigma squared x plus sigma squared y. And that's your formula for sigma s, okay? And this is what we refer to as the Pythagorean sum. This is what I call the Pythagorean sum. It's not a sum, but it's a Pythagorean sum. The square root of the sum of the squares, okay? All right. So to summarize, what do we have so far? What is the distribution of s equals x plus y? For any two random variables, x plus y, if I add them together, I simply, if I want to do the average, I simply add the two means or the two averages. If I wanted to do the variance, I can simply add the two variances. But if I wanted to do the standard deviation, I do not add the individual standard deviations. I take the square root of the variances, right? The sum of the two variances. All right, that's what we have so far. Okay, so what is the distribution now? So that is the sum. Now we're going to be looking at the difference. Okay, so how is it going to change if I subtract? Again, we're going to build the probability distribution. It's going to take time, but I want you to understand why things are the way they are, rather than just me giving you the formulas. Okay? All right, so here we go. We got, how do we get a difference of 0? Well, we get a difference of 0 by taking, this is going to be a little easier because I can just scroll up now. I take the difference of 3 minus 3 is 0. And then I could just, okay, so then I need to do this probability times this probability, 0.25 times 0.4. And that's how I get the answer for that. Now, how do I get a difference of negative 3? I simply do 6 minus I would have to do, sorry about that. I'd have to do, if I went -3, I would have to do 2 minus 5, right? 2 take away 5. That's how I get -3. All right, so I want -3. So I have to do 2 minus 5. That's how I get that. How do I get a difference of -2? All right, let's go back. -2. There's a couple ways to do that. You can do 2 take away 4. I can do 3 take away 5. There's only 2 ways to do that. So 2 take away 4, 3 take away 5. All right, and then of course to get -1, there's 3 ways to do that, just like we did before. All right, so that's what we're going to be doing. We got the sigma x's. I have these for reference, so we could just use those. All right, so again, so we're going to have to do this here. To get d equals 3, -3, we would have to use, what did we say we would have to use? We said we'd have to use 2 and 5, right? So 2 and 5. Okay, so the probability for Pete for x equals 2 is 0.15. We get 0.15. For Aaron, y equals 5, it was 0.1. Multiply those, you get 0.015. I'm going to go a little faster through this because we had done this with the previous thing, okay? So d equals -2, so that's 2 and 4, or 3 and 5. Okay, so we got x equals 2, y equals 4. Pete's x equals 2 is 0.15, and Aaron's y equals 4 is 0.2 from her table. You get 0.03. All right, x equals 3, 5, so we got 3 and 5. For Pete, x equals 3 was 0.25. For Aaron, it was 0.1 for 5. And you get 0.025. Add those together. You get 0.055. So again, we can put that in the table here, 0.055. Again, going a little bit faster. All right, so for d equals -1, there are 3 ways. There are 3 ways to do that. You can do x equals 2, y equals 3, so that's 2 minus 3. You could do Pete's x equals 3, Aaron's y equals 4, or you can do Pete's y equals 4 and Aaron's y equals 5. Okay, so 2, 3, 3, 4, or 4, 5. So x equals 2, the probability for that was 0.15 for Pete. It was 0.25 for this one. Okay, and then for Aaron, y equals 3 was 0.4. So you multiply those, you get 0.06. For Aaron, y equals 4 was 0.2. Multiply those, you get 0.05. Pete's x equals 4 is 0.35. Aaron's y equals 5 is 0.1. So you get 0.035. Okay, going through this a little faster because we've already done this kind of process. So you add these together, you get 0.65. Okay, so we have this is 0.65, or this. Okay, so we got 0.015, 0.55, and 0.65. Okay, so hold on here. I think I put this in the wrong spot. That should say 0.015, right? Not 0.055. This is 0.055, and then this is 0.65. All right, there you go. That's what we have. Okay, so now we can do the sum of the d's, right? This is the average. So you take the difference times the probability. So the first difference was -1. The probability of -1 we said was, or no, the first difference was -3. Sorry, -3. And then the difference for that was, we just calculated that. It was 0.015. Okay, times 0.015. Plus, then do the second difference for d equals -2. The probability for that was 0.055, and so on and so forth. Dot, dot, dot. And we get a difference of 0.65. Or is it 0.65? Hold on. Okay, what do we get the difference of? Oh, what am I doing here? I'm sorry, guys. This is 0.145. I'm bad math here. 0.145, okay? This is 0.65. I was looking at the two numbers. I had a bunch of numbers that I thought of. Okay, so sorry about that. 145. So you can change that later if you want. Okay, so 0.65. That's 0.65. Sorry about that. Now, notice to get 0.65, I can take the two numbers for Pete and Aaron. You probably guessed that that's what we could do, right? Since that's been the same type of pattern that we've had. So you can take Pete's number and Aaron's average and subtract those. Oh, okay. I am just losing it right now. So we got mu x minus mu y. So we get 3.75 minus 3.10, so 0.65. Okay, so mu x minus mu y, you get 0.65. And so we can just subtract them and get the same exact result. We don't have to do all this stuff, right? It's a good exercise to make sure you understand, but you don't have to do it. We can just subtract them. All right, now for the standard deviation, we're simply going to give you that value, okay? We're not going to, so when you do this, you get 2.0775, okay? You're going to do do it on the all in the calculator. All right, so now the sigma squared, notice that this number, you can get this number by doing sigma squared x plus sigma squared y. 2.0775, isn't that what we had earlier? That's what we had when we added those. So it was 1.0897 squared, 0.943 squared. And you get this is exactly word for word what we had, or number for number, what we had for the other one, 2.0775, pretty similar. So what you do is you just simply add the two variances just like we did for the other one. However, this does not equal sigma x plus sigma y, right? Or it doesn't equal sigma x minus sigma y, right? That's another thing here. Sigma s, or this is not sigma s, guys. This is sigma d. I should say sigma d. It doesn't even equal sigma x minus sigma y, right? Because remember we subtracted the two things. It doesn't equal that either. It doesn't equal that, nor does it equal sigma x plus sigma y. All right, which, if I added these together, I would get 2.0327, right? Which is not 2.0775, or which is not, remember that let's do the square root of this. The square root of this, we said, was 1.441. It doesn't equal that either, okay? So in other words, the variance of the difference of two independent random variables is the sum of their variances, same as it was before for the addition of the variances. To find the addition of x plus y. To find the standard deviation, take the square root of the variances. Okay, so again, the sigma x minus y equals the square root of sigma squared x plus sigma squared y. Which, notice, that's the same formula as sigma x plus y. Same formula as sigma x plus y is the same formula as sigma x minus y. Okay? All right. So let's summarize, because there's a lot of information, so we want to make sure we can summarize what we have done so far. Okay, so let's summarize. What's the distribution of d equals x minus y? For any two independent random variables, x and y, if I subtract them, the mean is when I subtract the two means. The variance, I add the two variances. The standard deviation, I take the square root of adding the two variances. Okay? Now let's compare that to mu s. For mu s, s was x plus y. Mu s. was mu x plus mu y. Sigma squared s was sigma squared x plus sigma squared y. Same thing here. Sigma s is square root of sigma squared x plus sigma squared y. Same thing. So the variance and the variances and the standard deviations are the same. The means are different. Okay, one is plus, one is minus. All right, so go ahead and pause the video, see if you can try the check for the plus and for the minus. All right, so hopefully you paused it and tried it. So we got Pete charges $150 per passenger. Aaron charges $175 per passenger. Let C equals the amount of money Pete collects, and E equals the amount of money Aaron collects. All right, folks. So we want to find mu C and mu E. I don't know. I'm not sure why it's doing it on the top like that. It should be going on the bottom. All right, so define S equals C plus E. Calculate and interpret the mean of S. Okay. Again, it says interpret, but we're not gonna write it out. We're just gonna do the calculation. I just wanted you to do the calculation. We'll talk about the interpretation as well, but we just want to do the calculation. All right, so now this should say part A. Sorry about that. Part A, find mu C and mu E. All right. So mu C, to find mu C, you have to just do all this on the calculator. Okay, so you basically, okay, so now we can do this easier if we know that, okay, well, we know that it's 175 per passenger, so it's basically, okay, oops. Remember that Pete's variable was X and Aaron's variable was Y. So we have mu 175x, or no, 150x, because Pete's charging 150. So it's 150 times mu x. And remember that Pete's mu was 3.75, and so we can get his from that. Now for Aaron's, it's 175x. So we can do 175 mu y. Sorry, Aaron's is y. And remember that we had done this already. The mu y for Aaron was 0.943. So you're just referring to the previous in the notes. Okay, so then we can calculate that. All right, so we get 562.50. And then Aaron is 542.50. Okay. Okay. Okay, so that's what we got. So that's part A. And so now for part B, we want to do S plus E. Okay, so the mu of C plus E, which is mu S, is simply the sum of the two means. So we add them. So 562.50 plus 542.50. And we add them. We get $1,105. That's an 11 here, not a 6. $1,105 even. So what that means, if we were to interpret it, is over many randomly selected days, we would expect that the average, the typical amount of money made by Pete and Aaron's tours combined is $1,105. Okay. All right, so let's calculate sigma C. So now sigma C, remember, has to do with the 150 times, he charges 150. So it's 150 times the standard deviation for X. Remember, multiplication affects mean and standard deviation. Okay, so we could just do 150. Now, Aaron charged 175, so that means it's going to be 175 sigma Y. Okay. Sorry about that. I'm trying to erase that. Okay, so then we can just multiply those. All right, so 150, what was sigma x? For Pete, sigma x was 1.0897. And Aaron, her sigma y was 0.943. So we get $163.46, $165.03. All right, so now we're going to define, now we're going to do C minus E, okay? So we want to do the standard deviation. We don't, again, we're not going to interpret it, we're just going to calculate it. All right, so sigma D, which is sigma C minus E. So again, the formula is, remember what we said is we do the Pythagorean sum, okay? So the Pythagorean sum is that. Now, if we wanted to do the mean, we would subtract, right? We would subtract mu c minus mu e. But here we're doing the standard deviation. So we do the square root 1.0897 squared and then 0.943 squared. So you get $232.28. All right, that's our guy. Okay, so hopefully that made sense, you know, with addition, subtraction, the whole thing, okay? A lot going on there. Okay, so let's look at, let's just summarize what we've done with linear combination for learning target 2 and wrap up learning target 2. Linear combination of random variables x and y. If ax plus by is a linear combination of the random variables x and y, then to find the mean and standard deviation, so here it should say, this should say mu ax plus by. So then to find that, we would have to do mu ax plus mu by. We add the two different ones, right? Because we're adding. But remember that a is multiplying and b is multiplying. And so we're going to multiply the mean by the a and by the b for the y. Okay. There you go. That's a good formula for that. Now for sigma, remember that sigma is not affected at all by, you know, well, the sigma is, the rule for sigma is way different, right? So the rule for sigma is we have the Pythagorean sum, right? The Pythagorean sum of the ax squared plus the by squared. We have to do the sum of those, just like we did earlier in the check. But then what does a do? Since a is being multiplied and b is being multiplied, you can multiply this. Remember that the standard deviation is affected by multiplication. So what we're going to do is we're going to simply multiply the a, multiply the b. And so then the final result is square root of a squared sigma squared plus b squared sigma squared. And that's the final result, okay? All right, now let's do an example. So if I have x minus y, what would I do? Well, I would keep in mind that this is the same thing as x plus negative 1y, right? And so when I use the formula, I would say, okay, well, a is 1, so I get 1 squared. And b is negative 1, so I get negative 1 squared. But 1 squared plus negative 1 squared is positive, 1 squared is positive. So I simply get sigma squared x plus sigma squared y, which is exactly what we told you the result was earlier, okay? All right, that concludes learning target 2. All right, so learning target 3, find probabilities involving the sum or difference of independent random variables. All right, so now what we're going to do is what if we combine two independent normal random variables? So we talked about just generic x and y, combining them, adding, subtracting them, whatever.
But it turns out it works the same for random variables. Okay, so any linear combination of independent normal random variables is normally distributed. Okay, so I should say normal there, is normally distributed. And so the same rules apply. We have the same general rules. If you add or subtract the variables, then that result is going to apply to the means. If you add or subtract the variables for the standard deviation, or when you calculate the standard deviation, it's still going to be the Pythagorean sum, right? The square root of the sigma squared plus sigma squared, right? Okay, so those rules still apply. All right, so example 3. Mr. Starnes likes sugar in his tea, in his hot tea. From experience, he needs between 8.5 and 9 grams of sugar in a cup of tea for the drink to taste right. While making his tea one morning, he adds 4 randomly selected packets of sugar. Okay, so he needs it between 8.5 and 9 grams. He adds 4 randomly selected packets of sugar. Suppose the amount of sugar in these packets follows a normal distribution with a mean of 2.17 grams and a standard deviation of 0.08 grams. What's the probability that his tea tastes right? Okay, so we're going to say that X is the amount of sugar in a randomly selected packet. So we have 4 packets that he put on there: X1, X2, X3, X4. So the variable T is going to represent the sum of those amounts of sugar in those packets. Okay, so X1 plus X2 plus X3 plus X4. Okay, and so if I wanted to find mu T, well, that's going to be the sum of mu x1 plus x2 plus x3 plus x4. But as we mentioned, you can just simply add the individual means, right? However, the individual means are the same for all of them. So they're all mu x, okay? So in other words, mu x1 is equal to mu x2 equals mu x3 equals mu x4. They're all equal to mu x, right? And this is mu x, 2.17, okay? And we got sigma x is 0.08 according to this, okay? So this is gonna be 4 mu x, so it's 4 times 2.17, which is 8.68 grams. Okay, now we're going to do the variance. So the variance is going to be the sum of sigma squared x1 plus sigma squared x2 plus sigma squared x3 plus sigma squared x4. But as we mentioned, they're all equal to sigma, right? So really we just have 4 of these, 4 sigma squared x. So we have 4 times, now sigma we said is 0.08, so it's 0.08 squared. Okay, so we get 0.0256 grams squared. And now to find the standard deviation, we simply take the square root of that number. We get 0.16 grams. All right, so we got the standard deviation, we got the mean, 0.16 and 8.68. So now what we're going to do is we're going to label the normal distribution for this situation, and we're going to use those numbers, right? So we got 8.68 has to be in the middle because that's the mean, right? This is for S, the sum, right? Okay. And then the standard deviation is 0.16, so we're going to add 0.16, subtract 0.16 to get those numbers, to get the other numbers. All right, and then add another 0.16, and then add another 0.16, 9.16, and then subtract 0.16, we get 8.52, 8.36, and then 8.20. All right, so we want it to be between 8.5 and 9 grams for his tea to taste to be just right, okay? So x2, I guess that should be sum 2, sum 1, right? So sum 2, sum 1, I guess, if you technically want to call that. Okay, so we want to find the probability that the total amount of sugar is between 8.5 and 9 grams, okay? Okay. Oh, okay, it says x equals the amount of sugar, okay. All right, so I just want to double check that. All right, so now we're going to use a z-score formula, but we're going to use it twice, right? One for 8.5, one for 9. Let's do that here. Okay, so we got 8.5 minus the mu x. The mu x is 8.68. The sigma was 0.16, so we got that. And then here we got 9 minus 8.68 divided by 0.16. All right, so let's do the first one. So we get this 1/8 divided by 0.16. So this is going to be negative 1.13. And then the next one, well, it should be 2, right? It should be 2 for the, yeah. So 2 or 2.00. Okay, so now we want the probability that it's between those two z-scores. And so in order to do that, we need to subtract the two individual values from the table, okay? So we'll go ahead and do that. Negative, the first one, 2.00. Okay, so let's go up 2.00, 2.00. That's 0.9772. So we'll write that first value. And the next one is negative 1.13. Negative 1.13. So that's 0.1292. All right, so we're going to subtract those. We'll do this on the calculator real quick. You get 0.8480. So there's about an 84.8% probability that it tastes just right. Now we're going to, well, we can round it to 85% or whatever. But let's use the calculator. Remember how we do this on the calculator? So we're going to do the normal CDF, right? The normal CDF stuff. We get the lower equals 8.5 because we're doing between, I forgot to shade this. 8.5, upper equals 9. The mean is 8.68, and then the standard deviation is 0.16. Okay, and you do that on the calculator, and you should get a similar result. All right, go ahead and pause the video and see if you can try the following problem. All right, hopefully you paused it and tried it. So, and then, and that way you can check your work and see if you kind of understand it. Ken is traveling for his business. He has a new 0.85 ounce of tube of toothpaste that's supposed to last him the whole trip. The amount of toothpaste he squeezes out of the tube each time he brushes can be modeled by a normal distribution. All right. You get a mean of 0.813, you get a standard deviation 0.02. If Ken brushes his teeth 6 times on a randomly selected trip, and the amounts are independent, okay, so 6 times, what's the probability that he'll use all the toothpaste in the tube? Okay, and the toothpaste is 0.85. Okay, so 6 times with an average of 0.13. Okay, so we got mu x is 0.13, sigma x is 0.02. So we could label it and use those, but we're gonna try to do the sum here. We're not just doing the mu x and the sigma x. We're doing the sum, right? So let me get rid of this here. All right, so now we're gonna do mu s, right? So now this is gonna be s, the total. Now 0.13, he's doing it 6 times, so it's gonna be 0.13 plus 0.13, or 6 times mu x, okay? So 6 times 0.13, which is 0.78, all right, ounces. And then the standard deviation is going to be 6 times the standard deviation original. Oops, be careful with this here. Now I want to point something out because this is an error right here. I want to show you why. This is a common error. It's very easy to make this error because you have 6 mu x, and so you think, oh, 6 sigma x, right? No, it's actually not that. Notice that it's not going to be 6 sigma x. It's actually going to be the square root, okay, when you do this. So you have to be very careful with this, okay? So I'm going to put a little note here, right, just so you were aware. Very important side note, okay? I'll actually put it up here. That sigma 6x is not the same as sigma x1 plus x2 plus x3 plus x4 plus x5 plus x6. They are not the same thing, okay? Even if they are, so in other words, it's not the same as, you know, the sigma x1 plus sigma x2, okay? Be very careful. Because sigma 6x is equal to 6 sigma x, right? But sigma x1 plus x2 dot 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 plus x6 is actually equal to the square root of 6 sigma x. Assuming that sigma x1 and sigma x2, they're all the same, okay? This is assuming that these are all identical, okay? Okay? All right, so be very careful with that. I'm going to explain that more when we do this problem. Okay, so I'm going to do this problem right here. I'm going to show you this. So I almost made a mistake here. So be very careful to not make the mistake that I made because it's very easy to make. Very. So first, we're going to write this as sigma squared. This is something that they like asking on the multiple choice or whatever, or free response to make sure you understand. We know that the sum of the variances is the variance squared of the sum is the sum of the individual ones. Okay, so we'll start there. Dot 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 all the way to x6, right? And we know that the individual standard deviations are the same for all of them. So we know that this is equal to sigma squared x plus sigma squared x 6 times, right? So we can combine these into one standard deviation and get that 6 sigma squared, right? Now, if I take the square root of that, I get the square root of 6 sigma squared x, which is the square root of 6 times sigma x. You see that? Very different result. Square root of 6 versus the 6. Be very careful with that, guys. Very deceptive. Deceptively simple mistake to make. All right, so let's go ahead and do this now. So we got square root of 6 times. Now, the reason why we do this is because these are independent packets. And because they're independent, it's an independent sum, we have to do it this way with the square root. If they told you that the formula for one packet is 6 times as much, then you would use this formula. Okay? Can't stress that enough. All right, so sigma x is 0.02. And we're going to do this calculation, see what we get, times 0.02. So we get 0.049, around there. We're actually rounded to 0.05. Let's just round it because it makes it a little easier. Okay, approximately. All right, so now we got 0.78. And we're going to go by 0.05. So 0.83, 0.88, 0.93, and then subtract here 0.73, 0.68, and then 0.63. And again, this is the sum S for the packet, okay? Or for the sum S for the toothpaste. Okay, so now he's brushing his teeth 6 times. What's the probability that he'll use up all the toothpaste? That means he use up all the toothpaste. That means he's got to use up either 0.85 or more, right? So 0.85 is how much he has in the thing, or more, right? That means, if he has to use more than the 0.85, of course he's going to need another toothpaste bottle, right? But we want the probability that he'll reach to 0.85 or more. Okay, so there you go. So the probability of that. So now let's convert that. So now we're just going to use the calculator for this. We're not going to do the z-score. I mean, you could do the z-score. Well, we'll do both. We'll do both. So we're going to do z equals value minus the mean over the standard deviation, which was 0.05. So that's let's just do the math here on the calculator. So it's 0.07 divided by 0.05, so 1 point something. So 1.40. And so the probability that z is greater than that is, now the table gives you the area to the left by default. So we haven't done too many. We've done chapter 2, but we haven't done too many of those in this lesson. So we'll just go over that real quick. So we got 1.40 is 0.9192, but this gives you the area to the left. So if I want the area to the right, I got to subtract from 1, okay? So 1.4. So 0.9192, subtract that from 1. One minus 0.9192, which is 0.0808. Okay? Now, of course, you can use the normal CDF, so I'll show you how to do that. The lower is 0.85. The upper is infinity, right? Because it just goes on forever. And we can't write infinity, so we write a really big number. So write like 10,000 or something like that, because it's here and on. And then the mean is 0.78, standard deviation is 0.05, and you should get a similar result. All right, that's going to do it for the video, guys, in Learning Target 3. Hope you found this useful and informative, and as usual, I'll see you in the next one.